Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy is going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everybody. Welcome to Wednesday Night Math Night. I am so excited to be here with everybody. Like Dr. A said, I am Amy Sink, and I am one of the math specialists here at the Learning Liaisons. And we just absolutely love what we do. We love helping teachers just feel more confident in their math skills. We love teachers feeling more confident as they walk into those tests that they're getting ready to do, and that's you. So we are so excited to be here. We are here every Wednesday, and so join us every Wednesday as we work through some math problems. I mean, it's really my pride and joy to just sit here and work math problems out with you. So that said, I always like to do, I'm trying to get like my life situated over here. I always like to do a get to know you question. So before we begin, let me know in the comment box where you're from, what test are you prepping for, and are you watching the NBA like finals right now? We are watching it only because we are Dallas Mavericks fans in our house. We're Dallas everything, Dallas Cowboys, Dallas Mavericks, the Texas Rangers. So are you watching the NBA finals? And if so, who are you rooting for? I know it's not the finals. It's like the semifinals. The Celtics, I think, just beat somebody, and the Mavericks are currently against the Timberwolves. It's a whole thing. So are you rooting for anyone? If not, what sport do you prefer to watch? And if no sports, and you're like a Broadway person like me, or you don't like to watch anything like that and you're a reality TV junkie or something else, that's fine too. I am a Broadway junkie, and so I'm a sports lover by proxy because my husband loves sports, and I do like sports, but I am definitely more of a theater girl. But like more like a Disney theater girl. Like I like, Finding Nemo and Peter Pan and Aladdin and Wicked and stuff like that. So I'm not like a Les Mis kind of theater girl. So I'm not really a theater girl, I guess, if you would say it. Anyways, it has been a long day, y'all. And so you might just catch me blabbering on. So with that said, I am excited to be here. In the comments, you can also let me know what you're struggling with. Like, is there something that you want me to go over in the next couple of weeks? Because that is why we're here. We're here for you. We're not here for me. We're not here for somebody else. We are here for you. So if there is something that you want to see me go over in the upcoming weeks, just let me know in the comment box, because I love to build my sessions around the needs of the viewers, and that's you. So there are a couple of problems tonight that you'll see that are literally built out of specific requests that came out of last week or on Facebook. So if you have a specific request, let me know. I would love to include that as a part of our upcoming sessions. I think that's all the housekeeping I have for today. So let's go ahead and get started with our first problem. I'm going to add my next week slides here. So when you comment stuff that you want to see me go over in the upcoming weeks, I will just include it right here on my list so that I remember to include it. Let's go ahead and get started. So you're going to notice today a few problems as like a 1A, 1B, because I really thought that it was important to show you that like one scenario could be asked in multiple ways. So let's go ahead and read this problem. Hey, Susanna, how are you? Good to see you. I love when people say hi. It makes it feel less like I'm sitting in a room by myself looking at this computer. All right. Excuse me. Alex is buying supplies for his school project. He finds that the supplies cost $80 in total. The store is offering a 10% discount on all the items. After the discount, Alex needs to pay a 7% sales tax on the discounted price. What is the total cost of the supplies? All right. So I had somebody ask, and I'm going to put like a little asterisk next to this because this was a specifically requested question. I had somebody ask for like all things GK, and this is truly all things GK. When we look at this problem, this is a very typical GK problem. However, it really could be seen on a K6 test. It could be seen on GK. It could be seen in middle school, and it could be seen in high school. So when we look at this, we need to have like a plan of action. So Alex is buying supplies for his school project. I had to roll up my sleeves. He finds that the supplies cost $80 in total. Okay, so there's like a critical piece of information, right? The store is offering a 10% discount on all items. So ultimately, they want to know what the total cost of the supplies is after these discounts and the tax and all of that. The store is offering a 10% discount. So step one, I need to figure out the cost of the items with the discount. Then it says after the discount, Alex needs to pay a 7% sales tax on the discounted price. So number two, I need to calculate my sales tax. And then I need to figure out my total, right? So step one, what is the cost of the items with the discount? So a discount, when I'm looking at a percentage off, I can either move that decimal place and multiply my total amount times, so my discount is 10%. I can hop my decimal 2 places to the left. That's how we convert a percent to a decimal. So my K3 people or my K6 people, you may not see this entire question, but understanding discounts and percentages and all of that is absolutely necessary. So knowing how to convert between decimals and percents is super critical. So I can multiply 80 times 0.10, and then that will give me the discount off. Or I can multiply 80 times the remaining amount. So if the store is offering a 10% discount, I'm paying 90% of the cost, right? So I could multiply 80 times 90%, and you'll see what's going to happen. So 80 times 0.10 is $8. That is the price or the discount that I'm taking off the top. So I can do 80 minus 8, and that gives me $72. That's how much I'm going to pay. Or I can do 80 times 0.90. So I'm going to open my phone, use my calculator. 80 times 0.9 is 72. That's the amount that I'm paying. Either way works, whichever way is better for you. So now I've figured out how much I'm paying after the discount. Now I need to figure out what that 7% sales tax is. So I'm going to take that 72 and multiply it by my sales tax. So here we have two options too. I can multiply 72 times, now remember, when I convert a percentage into a decimal, I need to hop that decimal 2 places to the what? To the left. So if I'm hopping that decimal 2 places to the left, 7% is not going to become 0.7. 7% is going to become what? 7% is going to become 0.07, right? So I need to multiply. So 7%, when I hop that decimal, I end up with that 0 in the front of it. So I can multiply by 0.07. 72 times 0.07, $5.04. That is my sales tax. That is the tax. So what do I need to do with that number? Add it to the 72. So 72 plus $5.04 is $77.04. So my answer is B, because we're looking for that total cost. However, some of you might prefer less steps. So you can also do 72 times 1.07. Watch what happens when I do that. 72 times 1.07, $77.04. When I multiply the 72 times 1.07, that method works when you're having to take a number and then add it. So it works in a sales tax mentality. It's not really going to work in the discount mentality, because the discount mentality, we're going to multiply it by that 90%. But in the addition world, where I'm multiplying by 7% and then having to add it to my total, the 1 represents the whole or the total that we have. So by multiplying it by 1.07, what I'm telling it is that, hey, I want to take that 72, but I also want to add that 7% to it. So by multiplying the 72 by 1.07, that's really what I'm doing. However, I will tell you, every single time I solve these problems, I don't know why, it's just my go-to, I solve them this way every single time. It's just my natural go-to. So I'm giving you another option to solve, but you don't have to do it that way. In fact, the person coaching you is doing it the more inefficient way, because it's just the way that my brain understands. Capiche? Questions? All right, let's go ahead and go on to problem 1B. So you can see that they can take this same exact problem, this same exact scenario, and just ask a different question. Alex is still buying supplies for his school project. He finds that the supplies still cost $80. The store is offering a 10% discount on all items. After the discount, Alex needs to pay a 7% sales tax. All of that is the same. Question: how much sales tax does Alex need to pay on the discounted price? Now, what do you think is going to be the number one error here? And I like to sometimes ask these questions, and I don't do it often enough. Sometimes, so if we did like problem 1C and they said, what is the student's error? Because there is error analysis on a lot of our exams. A common error here is going to be multiplying the 80 times the 0.07 rather than finding that discount, because in this situation, we're not finding the total. And so when we read the question and we're in a hurry and our anxiety is a little high and we're kind of feeling all of those feelings, how much sales tax does Alex need to pay on the discounted price? People are going to go, oh, I know how to do that. 7% times 80. I know how to find sales tax. But people are going to skip over the whole there's a 10% discount. So it's important that we read the question in its entirety. Now, we already know what this question is about because we've already solved it. So yes, we would find the discount, 80 times 0.10, $8, subtract 72 minus 8. 80 minus 8 is 72, and then multiply 72 times 0.07, and we get $5.04. We already solved all of that, so we know the answer is B. But what I wanted to do was show you that the same problem can ask a very similar question. Does that make sense? All right, let's move on to problem number 2. All right, another very GK style problem. So if you are the person that asked for GK problems, this is your day. However, GK problems often translate K-12 because the GK spans from 4th to about 9th grade, 8th, 9th grade. And so it really, really spans the larger amount of all of us. So let's read this problem together and then go ahead and solve it. A farmer needs to compute the volume of his barn for storage purposes. The barn has a rectangular base measuring 32 feet by 15 yards. It's 4.5 feet tall on 2 sides, and it's 12 yards tall from the base to the peak. What is the volume of this barn? Y'all, this problem is a beast. If you are not fluent in this process, I would skip it and move on. If you are comfortable solving this, solve it. I tried it again today and was able to solve it in about 2 minutes. But when I tell you I was hustling through this problem. So if you are not 1,000% confident, it's not worth your time wasting 7-8 minutes on this problem when you can go through some other problems much quicker. Flag this one and come back to it. So if you see this problem on your test, I would flag it and move on. Now, I want you to know how to solve it. So we're trying to find volume of a prism. Now, my elementary people, you may not need to solve this problem. However, you need to know what a prism and a pyramid are. So knowing that, at least you can listen to some of that, right? A prism has 2 identical bases with rectangles around it. The number one error people are going to make is they are going to, when they do volume of a prism, which is area of the base times the height of the prism, people are going to assume that this is the base because this is a barn and the barn is sitting on the ground, right? But by definition, the base is the 2 identical shapes that are connected by rectangles. Well, the 2 identical shapes are actually this one and this one. Those are the bases of this prism. This is a pentagonal prism, which means we have 5 sides, 5 to our base, pentagon, and the height of this prism is not 12 yards. Yes, that is how tall the barn is, but the height of this prism is the distance that's connecting my two bases together. This is going to be the height of my prism. Confusing? Yes. Impossible? No. So let's go ahead and take a look, and I'm going to just highlight that base for us again so that we can understand what we're working with. So I need to find the area of my base. How am I going to find the area of my base? Well, my base is a not standard pentagon. So what I'm going to do is I'm going to find the area. I'm going to cut my base into two different shapes that I do know how to find. So big B is going to equal the area of my rectangle plus the area of my triangle. And yes, this is really what I would write down on my paper because this problem is multi-step and I don't want to get lost in the steps. So I need to do area of a rectangle. Area of a rectangle is length times width. Area of this rectangle right here, 32 times this length is 32. What is this smaller height right here? 4.5 feet. So 32 times 4.5. 32 times 4.5 is 144. So I'm going to move this up a little bit so I have a little bit more room. I found the area of my rectangle. Now I need to add that to the area of my triangle, but I just realized in this process that I have feet and I have yards. And I have feet and I have yards. Problem! I need to convert my yards into feet. Why not convert my feet into yards? Because my answers are all in feet. So, how do I convert yards to feet? 1 yard equals 3 feet. And if you are taking anything GK or above, you likely have a reference sheet that tells you this. So 15 yards is going to equal how many feet? And yes, this is how I do conversions every single time. So to get from yards to feet, how do I get from the number 1 to the number 3? Multiplication or division? Multiplication. 1 times 3 is 3. So 15 times 3 is 45. So that magically turns into 45 feet. And I need to convert my 12. So 12 yards equals times 3, 36 feet. Now I can find the area of my triangle. Area of a triangle equals, what is the formula for area of a triangle? 1/2 base times height. So 1/2 times the base of that triangle is 32. Because this was 32, right? So like this is 32, so this is going to be 32. What is that height of my triangle going to be, though? If I know that the entire thing is 36, and I know that this shorter part right here is 4.5, using my mentality of a part whole, elementary people, K6 people, using my mentality of a part whole mindset, 4.5 plus what equals 36? I can do 36 minus 4.5 to give me the height of my triangle. So 36 minus 4.5, 31.5. Now, is this barn realistic? Probably not. I made it up in my head. So it's probably not a realistic barn, and that's okay. So now I'm going to multiply 32 times 31.5 equals times 1/2 or divided by 2 is 504. Now, How many steps have we done, y'all? So many. So now you understand why I did this. Because it allowed me to track my work all the way down and not get lost in the weeds. Because if I was tracking that work all the way down, then I'm not going to get lost in the weeds, right? But if I'm tracking that, if I'm like just solving and it's all over the place, then I might forget what 504 even was. I might forget what I was even solving for because there's so many pieces and parts to this problem, right? So that's why you see I did that piece. So now I have 504 plus 144 equals 648. That is the area of my big base. Now the volume of my prism is just area of the base times the height of my prism, which we already discussed is that connecting piece between pentagon number 1 and pentagon number 2. What is that connecting piece? That connecting piece is 45. So 648 times 45. $29,160. So E is the correct answer. Questions about that? Let's go ahead and move on to the next section. Let's go ahead and move on to the next section. A square playground is built using 324 yards of fencing. About how many square feet does this fence contain? I'll read it again. A square playground is built using 324 yards of fencing. About how many square feet of fencing does this contain? Alrighty, so when we think about a square playground, I'm going to draw it. I'm going to draw it in green. Square playground. There's my square playground. And it's built using 324 yards of fencing. So let's go ahead and build some fencing. So here's my fencing. The fencing goes all the way around, right? And I know that side plus side plus side plus side has to equal 324. Which means 4 sides have to equal 324. How do I know they're all the same size? Because it told us that it's a square, right? So because it's a square, all 4 sides have to be the same. So I can literally take 324 and divide it by 4 to figure out how much fencing is on one side. Why is that important? Why do I need to know how much fencing is on one side? Because the question that was asked was, how many square feet does this fence contain? The question that was asked was, how many square feet does this fence contain? And if that's the question that's being posed, I know that I need to find area of a square, which is length times width, or side squared, because length times width is going to be side times side, which is the same thing, which is side squared, right? So if I'm doing length times width, then I need to know what the length of a side is. So 324 divided by 4, I'm going to do that in my calculator. 81. So that means that this side equals 81, and so does this side, and so does this side, and so does this side. And if area equals length times width, then I can just do 81 times 81 and get my answer. Pretty simple, huh? That equals 6,561. Questions? All right, that was a pretty quick problem. Let's go ahead and move on to problem number 4. This one's going to be another pretty quick problem. Which of the following shapes has equal angles? Which of the following shapes has equal angles? Parallelogram, rhombus, rectangle, or trapezoid? Parallelogram, rhombus, rectangle, or trapezoid. So, when we're talking about equal angles, this is an interesting question because a lot of times when we're thinking about properties of shapes, we think about equal sides, we think about parallel sides, we think about perpendicular sides, but we don't often talk about this idea of equal angles. So when we're talking about quadrilaterals, we know that a parallelogram could look like a pushed over rectangle. We also know that a parallelogram, it can be a rectangle, and we'll talk about that on, let me see. We'll talk about that in the next problem because the next problem is going to get a little bit more nitty gritty. But if I draw a parallelogram like a pushed over rectangle, is this angle the same as this angle? Absolutely not. This angle to the left is an obtuse angle, and this angle over to the right is an acute angle, and so those are nowhere close to being the same. So it's not going to be the parallelogram. The rhombus could be a square, but it can also be a pushed over square. And again, this angle is not the same as the other angle. This angle and this angle are not the same. You have an obtuse and an acute angle. So rhombus is out. But what kinds of angles do rectangles have? What kinds of angles do rectangles have? 90-degree angles. All the angles are 90 degrees. So if all the angles are 90 degrees, are they equal? They most certainly are. So rectangle is going to be the correct answer. A trapezoid does not have to have equal angles. In fact, when we think about like the standard block trapezoid, those are definitely not equal angles. Now, let's explore parallelograms a little bit further in the next problem. A rectangle exhibits which of the following properties? 2 sets of congruent parallel sides, 4 right angles, adjacent perpendicular sides, at least 1 set of parallel sides, or equal sides. A rectangle exhibits which of the following properties? So the format of this question, where it gives you like 1, 2, 3, 4, 5, and then you have to really disseminate that, is a common type of problem when we're discussing quadrilaterals or properties of shapes. And it can be overwhelming to really disseminate that information and figure out what is correct and what isn't correct. So let me show you kind of how I process through this. So 2 sets of congruent parallel sides. That, by definition, is a parallelogram. And a parallelogram can be a rectangle. A rectangle has, let's draw a rectangle. A rectangle exhibits Okay, there's my rectangle. Does this rectangle have two sets of congruent parallel lines? Yes, this is parallel to this, and this is parallel to this. And these are just like the parallel symbols. And this side is the same size as this side, and this side is the same size as this side. So a rectangle exhibits which of the following properties? Yes, two sets of congruent parallel sides. But even if I wasn't sure about that one, use your answer choices to help you. When I look at my answer choices, every single one of them has number 1, and every single one of them has number 2. I don't need to process through that. I don't need to decide if a rectangle has two sets of congruent parallel sides, because the answer choices told me that a rectangle does have that. The answer choices told me that a rectangle has 4 right angles. I don't need to figure out if that's true or not. Now, a rectangle does have 4 right angles, but I don't need to decide if that's true or not. All I have to decide is 3 true? Is 4 true? Is 5 true? So let's look at 3, 4, and 5. Adjacent perpendicular sides. If I don't know what that means, I'm going to skip it. At least one set of parallel sides. Is that true? Does it have at least one set of parallel sides? Well, yes, of course it does. Because in fact, it has 2 sets of congruent parallel sides. So of course it has at least one set of parallel sides, which means it's true. Well, when I go back to my answer choices, if I didn't understand what number 3 meant, it doesn't matter, because I just confirmed that number 4 is true. So I can cross off A, B, and C because I need 4 to be included. Does a rectangle have equal sides? Does it have to have equal sides? No, it does not have to have equal sides. Can it? It can, because a square is a rectangle, but a rectangle is not always a square. And so by definition, if this was a square, then a square would have equal sides. But this is a rectangle, and a rectangle doesn't have to have equal sides. So that one's out, which means I don't know why I crossed off C, because C is still in the running, right? So D is out because we don't want to include number 5. So C is the correct answer. Now, let's chat about number 3, because I skipped it pretending like we didn't know what it means, but I want us to discover what it means. Adjacent perpendicular sides. Adjacent means next to. So this side is adjacent to this side. And are those perpendicular? Yes, because it creates a 90-degree angle. This side is adjacent to this side. Are those perpendicular? Yes, because it creates a 90-degree angle. Same down here and same down here. So an adjacent side is the side that's next to the other side. These would be opposite sides, and these would be adjacent sides. That is important when we start to talk about trig, and we're looking at like right angles and theta and SOHCAHTOA, opposite, adjacent, hypotenuse. Hypotenuse is always across from that 90 degree, and opposite is across from theta, and adjacent is next to theta. So that is completely unrelated to this problem, but that adjacent vocabulary, opposite, all of that vocabulary is critical when we're thinking about what we need to know for these tests, right? All right, let's go ahead and move on to the next problem. This is another problem that came recommended, so let's go ahead and read it together. A traffic construction company is creating a road that is parallel to a railroad track, utilizing a coordinate grid system. If the road is not parallel to the track, it will cause potential collisions. The linear equation for the railroad track is 3x minus 4y equals 9. The proposed linear equation for the road is 3x plus 4y equals 5. What does the construction company need to do moving forward? A, nothing. The lines are already parallel. They can construct the road. B, multiply the equation for the railroad track by 16 over 9. C, multiply the equation for the road by a -1. Or D, multiply the equation for the railroad track by 4/3. All right, so this came highly recommended. Again, it's a problem similar to the one we solved last week where we were having to take two lines and do something to them to make them parallel or perpendicular. So I'm imagining we have a railroad track and we have a road that we need to be parallel to each other. And these are the two equations that I have that I'm working with, right? So I really just need to figure out if they're parallel or if they're not parallel and how to make them parallel. So I need to put them into slope-intercept form because right now they are in standard form, and standard form is not helpful when we're trying to figure out if lines are parallel or not parallel, or perpendicular or not perpendicular. How do I figure out, this is the real question, how do I figure out if a line is parallel or not parallel, perpendicular or not perpendicular, whatever? How do I figure that out? What information do I need? I need my slope. I need my slope because if they have the same slope, they are parallel. If they have negative reciprocal slopes, they are perpendicular. And I cannot figure out my slope in standard form. It has to be in some other form. Number one error people are going to make, they are going to say that these lines are parallel because they have the same slope, because they both have a 3x. Just because they both have a 3x does not mean they have the same slope, because this is not slope-intercept form. Let's manipulate these equations to make it that way. So I need to get the y by itself because slope-intercept form is y equals mx plus b. So I need to subtract the 3x from both sides. -4y equals -3x plus 9. Divide everything by -4. And I'm left with y equals negative divided by a negative is a whoosh, positive 3/4 x minus 9/4. Don't be afraid of fractions, y'all. They're not scary, I promise. They're just numbers like everyone else. Now let's go ahead and do this one. Subtract 3x from both sides. 4y equals -3x plus 5. Divide both sides by 4. Y equals -3/4 x plus 5/4. What do we notice? What do we notice? They do not have the same slope. No, ma'am. This one has a -3/4 as the slope. This one has a positive 3/4 as the slope. So I'm not going to do nothing because these roads are going to intersect. The railroad and the road are going to intersect, and that's not a good thing. We're going to have a crash. So we need to do something to make them parallel. I want my slopes to be the same. How am I going to make -3/4 and 3/4 the same? How am I going to make -3/4 and 3/4 the same? multiply the equation for the railroad track. Now, this one over here is the railroad track. And this one over here is the road. So if I multiply the railroad track this by 16/9, is that what I need to do? No, that's way too much. I don't need to do all that. I just need to make one negative or one positive to make them the same, right? So multiply the equation of the road by a -1. Yes. If I just multiply, not the equation. That's an error. Multiply the slope. If I multiply the whole equation by -1, I'm not changing the value of that equation. I'm changing the equation, the value of the equation is staying the same. So multiply the slope for the road by a -1. If I do that, I end up with +3/4. Railroad has +3/4, and we are winning in that situation. So I'm going to multiply the slope of the road by a -1, and I have the same slopes. Questions? All right, don't forget, I have a next week section loaded up, ready to go for suggestions. So if you have suggestions for next week, don't hesitate to put them in the comment box, and I will absolutely use that information to build the upcoming weeks of problems. All right, let's go ahead and move on to the next problem. We've done a lot of math tonight, y'all. Oh, this one was a request. Someone specifically requested, how do you solve inverse of matrices? How do you solve inverse of matrices? All right, let's go ahead and solve this. Find the inverse of the matrix. Okay, so inverse of matrix is interesting because when we think of inverse of everything else, we think of like the opposite or like the negative or something like that. Matrix inverses are like so complex for like no reason. So to find the inverse of the matrix, we have a series of steps we have to do. And if you don't know what those steps are, I mean, it's something that I have to Google every single time I do it. So like, I don't think it's something that we need to super duper like freak out about if we don't remember it. But that said, here's how we find the inverse of the matrix. So I'm going to take my original matrix, which is 2, 3, 1, 2. Okay. And I am going to flip these, but in this case, it's a 2 and a 2. So like flipping them is not really going to do a whole lot, but that's okay. I'm going to flip those so I have a 2 and a 2. And then I'm going to flip these and multiply them by -1. So this becomes a -1 and this becomes a -3. Are you following? Then I have to find the determinant of the matrix. So I am going to, now in like math terms, this is A, B, C, D. The determinant is A times D minus B times C before I flip and do all of that, right? So A times D is 2 times 2 minus B times C is 3 times 1. Now, if you do those in the wrong order, you will get the wrong answer, okay? So it's important that you know where A, B, and C, and D are and what order you're doing that determinant in. So 2 times 2 is 4. 3 times 1 is 3, so that equals 1. I'm going to take this new matrix that I have, and I'm going to multiply it by 1 over the determinant. I'm going to multiply it by 1 over the determinant. Well, the determinant was 1. So 1 over 1 times 2, -1, -3, 2. It's just 2, -1, -3, 2, right? Like it's nothing crazy. 2, And that's not even an answer choice because I messed it up. So 2, -1, -3, 2 is our final answer. Okay. Questions about that? All right, I think we have time for one more problem. This was actually a problem that was asked for on our Facebook page, so it's another request. So if the pattern continues, how many blocks will there be in the 17th figure? If the pattern continues, how many blocks will be in the 17th figure? Now, people love to have a formula or a process for these kinds of problems. And quite frankly, between you and me, I don't love memorizing formulas or processes that are not necessary. I am a huge proponent of figuring it out. So in figure 1, I have 2 blocks. In figure 2, I have 1, 2, 3, 4, 5, 6 blocks. In figure 3, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 blocks. What am I adding to each figure? And you can look at this in multiple different ways. I'm adding a row that is 2 more than the row before. So I started with 2. And then I added an entire row that included that 2, but then 2 more. And then I added an entire row that included that, but then 2 more. This is not an arithmetic sequence or a geometric sequence because I'm not adding the same amount every single time. So you cannot use the arithmetic sequence or the geometric sequence formula for this because I start with 2 and then I have 6 and then I have 12. And to get from 2 to 6, I added 4 blocks. But then to get from 6 to 12, I added 6 blocks. And then to get from 12 to the next one, I'm going to add 6 plus 2, which is 8 blocks. So plus 4, plus 6, plus 8, plus 10, plus 12, plus 14, plus 16, plus 18, plus 20, plus 22, plus 24, plus 26. That's what I'm doing. So you want to know what I'm going to do? Use my calculator. And I'm literally just going to go 2 plus 4 equals plus 6 plus 8 equals. And I'm going to keep doing that process. Now, I'm not going to write it all down because that's a waste of time in my head. I'm going to keep going until I get to the 17th time. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. How many of these do I need to do? 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. I need to add all of those. So 20 plus 10 plus 12 plus 14 plus 16 plus 18 plus 20 plus 22 plus 24 plus 26 plus 28 plus 30 plus 32. 272. That's how I would do it. I'm not going to waste my time trying to figure out a formula. That was easy enough, and it only took me about 30 seconds to do. Now, in order to make sure I hit 17 and I didn't hit 16 or 18 or something like that, I did write out what I was adding so I knew when to stop. I knew I needed to stop at 32. And so I just plus in my calculator until I got there. All right. Questions. Susanna, I see you. Student error analysis. $78.13. You got it. All right. Have a great week. Have a great time. It is summertime at this point. Most people are on summer break where I'm at. So enjoy your break, enjoy your summer, and I will see you all next week as you continue to prepare for this test. I'm going to shoot it back over to Dr. A, but if you have any questions at all, don't hesitate to reach out. I will see you next week.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.